Hey guys, welcome to today's class. So, as we're waiting to everyone get in, let's start with the lesson. All right. So what we're going to be going over today is basically sequences and series. Let's start with number one, basic knowledge. The following formula can be used to compute the sum of consecutive integers, or the sum of consecutive odd or even integers, or the sum of a series of integers that have a common difference. So x equals a plus b times n divided by 2, where a is the beginning number and b is the ending number. N is the n number of terms, right? And every consecutive numbers have a common difference of 1. And for a list of any numbers in a arithmetic series, there is a common difference. Or when you have two terms, three or more terms, these terms are 1, 2, 2, 3, 3, 4. These all have the same difference. That's called the common difference, as you can see in the rest. Alright, I let you guys have a try in this question, example 1, and tell me answers to chat. All right, let's get started with this question. So basically, how we're supposed to be doing this question is that 1 plus 2 plus 3 plus 4 all the way to 20. This sum is gonna be just 20 times 21 divided by 2. As we know, sum of the first n integers, positive, that are positive, is n times n plus 1 divided by 2, when the last integer is n. So, we get 210. So maybe you shouldn't have looked at this, but this is just a exercise to help you out. As you can see, it's 64. And then what the sum of all the positive multiple of 3 that are less than 100? Well, how many multiples of 3 are less than 100? 33. Think about this. Like, we do 3 times. We factor out a 3. And this becomes a sum from 1 to 33. Do we know what's the formula for a sum of the first 33 integers? It's just 33 times 17. And we just have to multiply by 3 again. And you can do the calculations, but I'm not. And the answer comes out to be 1683. I think that is right. You can test it out. That is indeed right. So basically, the whole point is trying to make it to something we can solve, and from there we just do do the steps reverse, basically. And like example 2, what was equals to 100? How many terms? There's 101, so there's a total of 100 terms. How many terms from 11 to 100? So if we want to find the number of terms that are integers from n to from k to n, for example, like k to be 2 and n be 7, the formula is n minus k plus 1. If we are including k and n. If not, then it's just you can just subtract ones from it if you want to not include n or k. In this case, it's just 7 minus 2 plus 1 or 6. And that is indeed true, as we have 2, 3, 4, 5, 6, 7. There's a total of 6. So this formula does indeed work. Now plugging it in for 111, we get the total numbers is 90. But now let's move on to example 4. Let's start this one first. And following swarm can compute a series of integers to have common difference. Is m times n, where m is the middle number, and how many numbers are in the addition. Now, what do I mean by m? Well, if there's an odd number in it, it's just the middle one. But there's a problem. The middle number is just the average of all the numbers. And in this a series case, it is indeed the middle number. But to expand to just a random sequence. It doesn't necessarily have to have a common difference. It can be randomly placed, like 1, 3, 6, 9, 14, and so on. Then the middle number is just the average of all the numbers, and then we multiply by n. Well, that's the same thing as just taking the sum of the numbers. So that formula might not be useful, but we're just given the average, and we're just given the first and last numbers in a sequence in a random order, and we know that they're equally spaced. That's basically how you're supposed to be doing it. The average is just that. It comes from the formula n1. The general formula was a1. If there's a sequence, a1, a2, a3, so on to an. And the sum is A1 plus AN, 2 times N. It's just the average of the first and last numbers, which is just the average or the middle number times the amount of numbers are there. So in this case, you can see these are examples. They're literally just applying it. So let's move on to example 4 now. I'll let you guys have a try on this question and tell me your answers through chat. All right, let's get started with this question. I hope you guys all had a turn on this question. So let's start. The sum of six consecutive positive integers is 2019. What is the largest of these integers? So there's 2019. And there's six. So the average is 373. 373.5. I think that's right. Well, let me calculate again. Uh, no, that was an overshoot. My bad. 26 is 18. So we get 3. And then we bring down 21. And 21 goes into 6. That's 3. 39, that's 6.5. Yeah, it's 236.5. And as we have here, this tells us the numbers are 336 and 337. This is the middle, and the right beside it is 336 and 337. And then we can just make the positive integers from there. 334, 335, 336, 337, 338, and 339. So the answer is 339. Make sure you have six positive integers fitting out, not like 5, 4, not like missing some of the integers, alright? Let's move on to example 5. The middle number method. Given the sum of consecutive integers, middle number of is the arithmetic mean of these integers. If we have an odd number of consecutive integers, the middle number is an integer. If we have an even, then it is not. Let's have a try on this question. I'll let you guys have a try on this question and tell me answers through chat and private message, alright? All right, let's get started with this question. So, basically, it's going to be three consecutive integers. One, two, three. And the sum is going to be six. It's pretty simple. We just write, for our first one, write a equation. Say the middle number is n. The Then the number after is n plus 1. Number before is n minus 1. This is the three integers. Add them up, give us 3n. Divide 3 in both sides, which is equal to 6, gives n equals 2. It's just a linear equation approach, which is probably the most simplest. The other way is just testing it out. Alright, let's get started on example 6. I'll let you guys have a go on this question and tell me the answers to chat. Okay, guys, I hope you guys all had a great try on it. So let's get started. So there's 101 consecutive integers that have a sum of 101. Alright, what was the largest integer in the sequence? Alright, think about it. It does not mention positive integers. That might be a great hint for those of you who are just starting it. Right? So if it says not, it doesn't even mention a positive, then there must be some negative integers. As you can see, there's 101 integers to be specific. So what number sum to 101? Hmm, maybe 101 is the last number? No, because then there's gonna be the sum of 1 and 100, which is too big. So we know that it's not one of these. It's at least it's one of them. Now, what if we said the middle number was m and let it and we have 100 off m? Is this equal to 101? We use one of the methods, right? And we get m equals 1. The middle of these numbers equal 1. So there's going to be 100 integers left. And then there's going to be 50 integers on both sides of m. So this means m equals 51. The greatest and positive, say. And the smallest is negative 49. So the answer to this question is C. So what we did is just, to summarize, all we did is using s equals m times n, where n is how many numbers, and then m is the middle number for a series. Alright, unless you guys have a try in example 7, and tell me your answers to chat. Okay, so let's get started. So basically, how to solve this question is the sum of consecutive integers from -22 to x inclusive is 98. What is x? Okay, so the total sum, we know it's going to go from 0 to something. It's -22 to 0. So that's the total of -253. And then we want to get 98. So the sum must be 253 plus 98 in order to make up for the 253. Gives us 351. And because of that, and we also, when we get that, the answer is, if we use 26 and times 27, is it going to be 26 times 27 divided by 2. So the answer for x is, I mean, yeah, so it shouldn't be 26. Just double checking. You must double check to not make sure that the problem, make sure the answer is correct. Like, for example, you might have got 26 times 77 divided by 2 is not 351. Let's move on to rules of consecutive integers. Positive integer n can be written as the sum of consecutive integers only when this positive integer cannot be expressed as the power of 2. Alright, so this might be true. So let's try an example that it isn't. Okay, so sum of consecutive integers, just n times n plus 1 divided by 2. And so this means that it's consecutive integers. Like consecutive integers don't have powers of 2, so that's proved. If a positive integer n has n odd factors, then there's n minus 1 ways to express n as 2 or more consecutive positive integers. Alright? 3 odd prime as sum of 2 consecutive positive integers, so on. And it just gives you some formulas. Alright? And this means over here, seal. So now, let's go have a try on example 8 with all these formulas, and tell me answers in chat. You can just read the lesson sheet if you want to look at the formulas, but I'm not going to explain them because we're running short on the time, as you can see. But basically, it's just formulas that can be easily derived. Can be derived using some basic knowledge. This is, like, for example, this one, we know that k factorial is the sum of the integers from k to 1. That's basically it. And you can just translate it across, so it's going to be proven from that. Right? So let's have you get a try on example 8 and tell me answers through the chat. Well, let's get started. So, the answer is, drum roll please, uh, B, not C. All right. So how do we get B? Oops. Sorry about that. How do we get B? There's a thousand consecutive odd integers. Mm-hmm. So it's gonna be, let's try to generalize a fact. All right, so let's say we have these numbers, 1, 3, and 5. How many gaps? Gaps, when I say gaps, it's just common differences are there. There's 2, and they're the same. But how many integers are there? There's 3. What about if there's 2 integers? There's only be one gap. So we can generalize that if there's 1,000 consecutive integers, then there's going to be 999 gaps. And we want to find the difference. Well, the difference is just the sum of all the gaps. As we can see here, if the gaps are 2 and 2, the entire gaps is 4. And that indeed is true. The 5 minus 1 is indeed 4. So, to solve this question, we just need to find the gap. First, common difference. 1 common difference. Write it as common diff. 2, find number of gaps. And then 3, just, let's say this is 1, this is 2. 1 times 2. This case, the gap is 2. The number of gaps is 999. 999 times 2 is 1998, which is just B. Alright? So this is the end of today's session. I hope you guys have a wonderful night. And I'll see you next week. Bye.